Dear students, yesterday we discussed how to find the indefinite integral of x raised to power n with respect to x by the definition method. Now today we shall discuss the indefinite integrals of some system functions. We will start with trigonometric functions. Like we know that the differentiation of sine x is cos x, which implies by this definition of indefinite integral of cos x with respect to with respect to x is sine x plus c, or simply the sine x. Now third one is differentiation of this e raised to power x is ex, which implies that the definite integral of this e raised to power x dx is ex plus c. Now here how we can also simply write, like in example, differentiation of cos x is minus sine x, which implies that d cos x equals to minus sine x dx, taking the integrals from both sides, which implies that integral of d cos x equals to minus integral, because minus is constant, sine x dx. Now here this is the integration. This d represents differentiation. Integration and differentiation are inverse to each other, so they will cancel. So we simply get here cos of x, which implies that this shifting this minus from this side, minus integral sine dx from this side, which is plus integral sine x dx, equals to simply minus cos x, or simply minus cos x plus c. So in this way we find the differential, or the integral, the indefinite integral of a given function when we know it is differential. Now if we consider differentiation of x with respect to x, which is 1, which implies that this indefinite integral of 1 with respect to dx is x plus c, which implies that integration of 1 is x with respect to x, or simply we can write integration of this indefinite integral of a with respect to x is ax plus c, because a is constant, using this very concept. So in this way you can find the indefinite integral of remaining 4 trigonometric functions. Let us take this inverse trigonometric functions, like d by dx of sine inverse x is 1 by root of 1 minus x square, which implies that integral of this very function, that is integral of 1 upon root of 1 minus x square dx, is sine inverse x plus c. Similarly, integral of this differential of cos inverse is minus 1 by root of 1 minus x square, which implies that the integral of 1 upon 1 minus x square dx is also minus cos x plus c. So this means that it depends upon situation. Now the integral of this 1 by root of 1 minus x square dx is either sine inverse x plus c, or it is minus cos inverse x plus c, because a differentiation of this sine inverse is 1 upon plus 1 upon root of 1 minus x square, or minus 1 upon root of minus 1 minus x square. Similarly, differentiation of this log is with respect to x is 1 upon x, which implies that the indefinite integral of 1 upon x dx is log x plus c, because in vast indefinite integral which we discussed, that is x raised to power n, that x raised to power n indefinite integral is x raised to power n plus 1 upon n plus 1, but it is valid only when n not equals to minus 1. Here if n is minus 1, that is 1 upon x, when we shift 1 upon x to numerator, we simply get x raised to power minus 1. So this means that when n is minus 1, and indefinite integral of x raised to power n dx is log x plus c when n is minus 1. But when n not equals to minus 1, then its integral is x raised to power n plus 1 upon n plus 1 plus c. Now you know that the differential of this exponential function, that is a raised to power x, is ax log a, which implies that the indefinite integral of this ax log a is ax plus c. Now here log a is constant, so it comes out from this integral, which implies that when it comes out from the integral here, it is in multiplied. So we can shift this side, that is it is ax upon log a plus c upon log a. Here c is constant, log a is constant, so constant upon constant is other constant is simply a constant. Hence we can simply say that indefinite integral of a raised to power x dx equals to ax upon log a plus c, where log a is constant. So in this way we can find the indefinite integral of each and every function by using the differential, by using the definition concept. Now what does this indefinite integrals, which is the family of curves, represent geometrically? Now let me consider an example f of x equals to 2x. Then its indefinite integral is integral of 2x dx. 2 is constant, so simply x dx. Now here n is 1, which implies that it is x1 plus 1 upon 1 plus 1, that is x square upon 2 into 2 plus c, which implies that it is x square plus c, because 2 cancels, we get x square plus c. This means that the indefinite integral of given function is x square plus c. So let's represent it is infinite collection of infinite curves. Because c is constant, it can take infinitely many values, which implies that we can represent by fc of x, capital fc of x. Now for particular values we get a particular curve. Like if we consider c equals to 0, then f0x equals to x square, which is parabola. Now when c is 1, we get f1x equals to x square plus 1. It is also a curve, which is the indefinite integral of this very function, that is 2x. Like c is 2, we get x square plus 2. Like c and f and x, we get x square plus n. So let us draw these curves, that is x square plus 1, so on to x square plus n on a graph. When we draw, this is x square, which is parabola. This is x square plus 1, which is parabola, but it touches the y-axis at y equals to 1. Similarly, x square plus 2, it touches the y-axis at at y equals to 2, or yn. This fn, which is again a parabola, and it touches the y-axis at y equals to n. Now let me consider a line which is parallel to y-axis. Now parallel to y-axis is of the form of x equals to a or x equals to minus a. So let's consider x equals to a. So this is here x equals to a line. It cuts the point in this parabola f0x, that is indefinite integral, this point at this point, this point, and this point. When we join, this is x equals to a. Also, to each and every curve of this collection, d by dx of fcx means a derivative of these infinite collection of curves at x equals to a is 2a, which implies that this means that the slope of tangents to each and every curve of this collection at x equals to a is 2a. This means that slope is same. When slope is same, they are parallel to each other. They are parallel to each other. Hence, simply we can say that at any point, the tangents at that point are parallel to each other. So geometrically we can say that this collection fcx means indefinite integral simply represents the family of parallel curves. Parallel curves means that when we consider any point on the domain and we draw a tangent at each and every curve of this collection at this point, if slopes are same, then we say that those are the parallel curves. So geometrically speaking, we can say that this fc represents the collection of parallel curves. So inshallah, in tomorrow's video lecture we will discuss few more properties of indefinite integral. So this is here the geometrical interpretation of indefinite integral. Like if we consider any other the line parallel to y-axis, like this y-axis, say x equals to minus a, when we find the slopes of tangents at this point. Now that slope is same to each and every curve for to each and every curve. This means that these are the parallel curves. So thank you.